So this question is, how large must the coefficient of static friction between tires if the curve is that radius at that speed?
Okay.
What is the equation we need to figure this out?
Okay, yeah, that's a good question. Okay, so we have, let's see. Static friction being between the tires and the road if around a level curve of radius. Okay, so you have like a curve of a road, right?
Yeah.
So it has a radius. Does it say this right?
Yeah, radius is 120 meters.
Okay, 120 meters is the radius.
And it gives us a speed.
Yeah, so then it gives us, let's see, so, yeah, so, okay, so that's our radius, so 120 meters, and our speed is what?
112 kilometers per hour.
Okay, so, basically, what's going to happen is, I'm going to erase this part, but we know it has a radius. So when it's going through the curve, what kind of forces does it have on it? What kind of forces does a car have on it?
It has a normal, centripetal.
Yeah, so this is like a bird's eye view of the car. So normal force is coming out, right?
Right.
Like out of the page, and then gravity's pulling down like this. Yeah, so we're going to have centripetal. So what direction is that going to be?
Is it pulling inward?
Yeah, exactly. Yep, so we have a centripetal force. So that's going to be m times AR. So that's the mass times the centripetal acceleration. So what other forces do we have? Is there any others?
Does that include net?
Net. Well, the net force would just be like the total on all of them. Yeah. So what about like friction?
Static friction.
Yeah. Yep. So we're gonna have friction pulling that way. So what we're gonna do is, since it's static, what do we know about these two forces?
Do they equal each other?
Yeah, exactly. So our net force is gonna be mass times acceleration, which is 0, right? That's 0. So now we're gonna look at the net forces. We're gonna look at just each like force individually. So we're gonna say this force, so the centripetal force minus the frictional force, and that's also equal to 0. So in other words, centripetal force equals frictional force.
Oh, okay.
Does that make sense?
Okay, yeah.
Yeah. So we're basically saying the sum of the forces this way, so this one minus this one, since it's a negative, since one's going the opposite way.
Yeah.
Both of these together are going to be 0. So if that's true, these have to equal each other, right?
Right.
Yeah.
So like they're equal to each other even though the car is turning.
Right. Yeah. So the reason, so it has no like net acceleration, but it's still. So it has a velocity this way, right?
Right.
But it's still turning in a circle. It's just not moving like outward is basically what it's saying.
Okay.
Yeah.
Okay. So
Yeah.
Fs equals F R.
Yeah. Okay, so what is this force going to be equal to? So let me rewrite this like over here, I guess. So what is this force going to be equal to? Like if we're expand it to a formula, what's the formula for it?
So mass times acceleration.
Yep. And that's going to be a radial acceleration, right?
Right.
Yeah. And then this one's going to be, what's the equation for friction? Do you know that one?
Oh boy. No, I don't.
Okay, so that one's going to be, so we're going to use mu, or our coefficient of friction. In this case, it's going to be static friction.
Okay.
And then it's times the normal force.
Okay.
Okay, so we can even expand this further, right? So we have its mass. So what is this one going to be equal to?
Like
what's our-
squared over r?
Yeah, exactly.
Okay.
So we have v squared over r, and then that one's good. What about our normal force? How can we like expand that? What's our normal force can be equal to? So we could like, let's draw this. So this is the car driving, right?
Right.
So we have, so looking at it from this way, we have gravity pulling it down, right?
Right.
We have a normal force going up.
Well, they cancel each other out, so it's 0.
Yeah, so, exactly, so, well, yeah, so
Or
they
they're one.
cancel each other out, so they're both, so that means that they must be equal to each other, right?
Right.
Yeah, exactly. Yeah, so since they cancel out, together they'll be 0, like up here. But since they're the only forces, so we could look at like, you know, the net forces on these two is going to be this force going up minus this one going down. Right, exactly, is equal to 0. So they're equal to each other. Yeah, so for this we could just put times mg.
Okay.
Does that make sense?
Okay, yeah. Yeah.
Yeah, so now we've expanded this pretty good, right? So what can we do right off the bat? Like,
We can cross off the masses.
yep, cancel masses, right?
Right.
So now we have v squared r, and let's just divide by g, right? Because this is what we're solving for.
Yeah.
So if we just divide by g, we get gravity down here.
Gravity right there.
Yeah, so since we're dividing by it, it's going to go down here.
Underneath the r or with the r?
With the r.
Okay.
Yeah, so if it like, yeah, so when you divide something like that,
Oh, I guess only algebra.
yeah, then you can just put it down there.
Alright.
Kind of weird. If you want to, if it makes more sense, you can solve for this, then divide by g too.
Alright, either way we get this right here.
Yeah, either way it
Okay.
should be like this. Yeah, so if you want it, at this point, if you have this, we can just plug in numbers, right? So r is going to be 20 meters. And then v, velocity. So what did you notice about velocity?
It's in kilometers per hour.
Yeah, exactly. So we want to get that to meters per second.
So that's 31.11. Because you divide it by 3.6.
Yeah. So okay. So yeah, exactly. So that's what it is. Okay, cool.
Yeah.
Yeah. So then we can just put that in here. That's meters per second squared.
And then we got static friction.
Yep. And then we can solve for a static friction. Yeah. So end up with like basically meters per second squared divided by meters per second squared. Units all cancel out, which is good because this is unitless, has no units. Yep, so once we do that math, we'll get our coefficient of static friction.
Wow. I really appreciate you going step by step and how to substitute.
Yeah, that's helpful, because I know like a lot of times like you see something like this, so you start out with like this, and then it goes to this, and it's like, how the heck did it go from there, you know?
Exactly, yeah.
So yeah, hopefully that's pretty helpful, just like breaking it down and yeah.
Would it have changed if you wanted kinetic friction?
Yeah, so okay, so if it wanted kinetic friction, what that means is that this frictional force is going to be bigger than this centripetal acceleration. So it's going to be like going forward and kind of like sliding like that.
Okay.
So instead of going in a perfect curve, it's going to kind of slide like over, and so it's going to have some net acceleration that way.
I see. Yeah, I see. And that would be given the problem.
Yeah, it would tell you. So then up here, what would change is you would now have you would now have an acceleration here, or some force. So you'd have like, you know, a 10 Newton force this way, and then you'd substitute 10 in here. And so instead of these equaling each other, you basically have to like, you know, you'd have a 10 Newton thing in there, and I don't know, you could still solve for it, just change a little bit, yeah.
Alright, cool. And then when we do problems, it gives us a static and a kinetic.
Yeah.
We do wet, right? Because we don't want to create a road only for dry conditions, right?
Oh, I see, yeah, exactly, yeah.
Alright.
Mm-hmm.
When we do that, will we do static or kinetic? What do you tell us?
He'd probably tell you, just like, so the rule of thumb is, like if there's a movement going on, then it will be in the direction of friction, then it's going to be kinetic.
I see.
And if there's no movement in that direction, then it's going to be static.
Okay.
Yeah. So this case, the car's not moving that way. It's just, they're equal, so it's going to be static. Or like, you know, in chapter 4 you have like, you know, like a box, and then like if you're pushing it, it's going to be kinetic, but if you're like, or if you're pushing it, it's moving, it's going to be kinetic, but if you just like push it and it's still, then it's static.